Hello, how's everyone doing today? Today we're going to be talking about Linux permissions, and we're going to get more into detail about the setuid, setgid, sticky bit, and also how to change permissions and symbolically and numerically. All right, so the first thing I'm going to do, I'm going to change it to the Sally user just to make things a lot more simple. And then from here, we can see that there's nothing in the directory that I'm currently in. If I type in ls, it's empty. There's nothing there. So the first thing we want to talk about is the permissions on the files or the directories. So what I'm going to do now, I'm going to make a file called file.txt. And if I do ls-l, which is the long listing, I'm going to explain this to you and then get into more details of how to read the permissions, okay? This is the symbolic version, which actually shows you with the letters drwx. So in this case, the first thing that you want to see is this hyphen or this tac, the first one right over here. All that means is that it's a regular file. All right, if you see a D, it means it's a directory. If you see a B, it means it's a block device, which is actually like a storage medium. So we see C, it means it's a character. So what that means is pretty much a character stream. So like you have data streaming in, like from your webcam or things like that. And then we also have the block. We have the C for character. We have the D for the directory. Then we have the dash for regular file. Then we have a S for socket. So this for like networking stuff. So if you see over here on the left side, we can see that is a tac. So it's just a regular file. The first three permissions is for the owner of the file. The next three permissions is for the group. And the next three permissions over here is for others. This period just means it's a regular file, like regular permissions are being enabled. And then this, how many links there are to this file. The first one is the owner, and then the group. So what this means is that the owner who owns this file, and then the group that owns this file, and then it's 0 bytes, and the last time it was modified. If we do the date, as we can see, we just literally just made it. So about 2 minutes ago, and it tells you here the last time it was modified. All right, so when we're talking about permissions, we're talking about three fields, which is read, write, execute, read, write, execute, read, write, execute, which the first three over here on the left side stands for the owner, the middle is a group, and the last three over here is for others. So this is the symbolic version of it. So let's say if I wanted to give the owner read, write, execute, and I wanted to give everybody else no permissions, I will do it like this. It will be read, write, execute, dash, 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 or tac, 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 right? So if we do this, as we can see, if you saw a file 1.txt just like this, it would mean that the owner has rewrite, execute, group has nothing, and everyone else can't view the file. That's exactly how it looks, all right? But we want to translate this symbolic to numerical. So how would you do that? R, which is read, equals 4, write equals 2, and execute equals 1. If you know how to add numbers, that's all you need to know. So if I want to give the owner read, write, and execute permissions, right? I'm going to add 4, 2, and 1. And what does that equal? 7. So if I wanted to do that, I would use a chmod command, which changes the mode bits. So basically what it's talking about is changing the bits. So over here, we're going to do 7 because we want to give the owner here read, write, and execute. And then we want everyone else to have read privileges, which is 4. So we'll give it 4. And then we want everyone else to have nothing. So if you want nothing is 0. Because 0 doesn't amount to anything, so it's not going to give it anything. And then I want to do it to file1.txt. And if I do ls-l, you can see now the actual owner of the file has read, write, execute. The group only has read, and everyone else has nothing. All right. So let's say if I wanted to give them read, write permissions, how would I do that? Because there's 3 fields. So the way we will do that in numbers is 4 plus 2, which we add 4 for read, and we have 2 for write. So the right way to do this will be chmod, and then we would use 6, and let's say we don't want to give permissions to everyone else, we'll give it 0. So this will give you read, write, and for everyone else, nothing. And if I did that, and if I did ls-l, we can see it's read, write, read, write. That's it. Very simple. All right, and when we're doing chmod, ls-l, when we're doing chmod, you can either do it numerical versions, like 777, and each number that you put in is corresponding to a field. So when we do 777, it's changing read, write, execute, and read, write, execute. So when you see these numbers here, it's just corresponding to a field on the left side. That's all that means. Okay? But and right now what we're going to do it symbolically. So we're going to use, letters. So the reason why this way will be handy is if you want to change one specific permissions, because if I'm doing chmod and I want to give like the owner like read, write, and execute, and if I just type this in, and I did ls-l, as you can see, that it's assuming that is the last one. If I did 777, I did it again, as you can see, it's assuming that it's the group. And if you have the 7 again, it's assuming that it's all of them, 777. But it's not really a good way to do it because it doesn't give you as much control as you want in terms of trying to get it fixed, because usually when you do when you change the permissions, you want to change it, you want to delete the old and obviously reconfigure it with new permissions. So when you do 777, it reconfigures everything. So if I did, let's say I want to do read, and then nothing for everyone else, and I did this, you see read, and nothing else for everyone. But let's say if I wanted to add the execute bit on the owner, this is how it would work. So remember, it's a little confusing because U here stands for the owner, group stands for group, and then everyone else is other. So over here, this is the owner of it, but over here, it's the user. So the user corresponds to this field, and then group is for the group, and then other is for everyone else. And it doesn't matter the order that you type these in. So if I do UGO, and if I do A, it means all of these fields I want it changed. So let's say if I want all those fields changed, you can use plus or you can use minus. Plus is for adding, minus is for minusing the bits. So let's say if I wanted to add execute to all of them. But before we do that, let me give you the options. We have sticky bit, we have the setuid, setgid, we have read, write, and execute. These are the possible scenarios on the right side. So on the left side of the command is what you're targeting, a user, group, or other. And on the right side of the command is like, what are you doing? Are you messing with the read, write, execute, sticky bit? What are you messing with? Right? The sticky bit and the setuid bit and gid bit will go over in further in the further lesson. But right now we will cover this, and once I'm done with this, I'll cover that part for you guys. So as we can see here, we have A plus, which A stands for all of the fields, right? And if I put U is for user, for the owner or user, right? And then G for group, and then O for others. So if I want to add execute to all those fields, I'll just do A plus X. And if I do ls-l, we can see that X, X, X. Hypothetically speaking, if you wanted to, you could do this. You could do 4 plus 1, right? Because 4 is for read, and then 1's for execute. I can do 5, and then I wanted to do read, write, execute on that one, so I can do 5, and then the last one I wanted to do execute, so 1. So if I did that, it should be exactly the same because it's not changing anything. It already exists, right? But if I wanted to use the chmod again, and I wanted to use the symbolic version, let's say if I wanted to change, if I wanted to give everyone, let's say everyone read, write permissions, right? No execute permissions, right? So let's say if I did this, if I did all, and then I did plus read, write, because I want everyone to have read, write permissions. And if you do ls-l, as you can see, it's adding it. It's not deleting the execute. So when you're typing in the numbers, like 777 or like 400, it'll actually modify all the fields to match this bit. So if there's no permissions on here, it will give it nothing. If there's no permissions, nothing. If this only has read permissions, it will take away the execute and the write permission, and it'll just give it the read. So when you're doing it numerically, it actually just changes it exactly how you want it. When you're doing it with the symbolic version, you're just either adding or taking away the bits. So in this case, if I wanted everyone to have read write but no execute, I would have to do a minus x after running that command. So I can do this, and then now you see it's rewrite execute. I mean rewrite, rewrite, rewrite. So remember, when you're doing it this way with the letters and all that, you're just basically being more specific of which part of it you want to hit. So like I want to just focus on the others. So for others, I want to do O, and I want to add an execute permission for it, right? So you do it like this. And then when I do ls-l, you can see the execute bit now exists because I'm specific, and O stands for other. And remember, you can do it any order you want. So let's say if you want to give the group and the user, so doing it this way or doing it that way doesn't make a difference. So if I want to give them execute permissions also, which effectively will be 777, you see execute here. And that's how that works. So when you're doing chmod, you can do the numeric, or you can do with the letters, and then you do plus, and then rewrite execute. And if you want to take away is rewrite execute like this. All right, next thing we're going to talk about is the setuid bit, setgid bit, and we're going to talk about the sticky bit. Okay, so when we're talking about special permissions, we need to understand that the setuid bit equals number 4, and then the setgid bit equals number 2, and I'll explain this to you in a second so you don't get too confused with this term. Or I guess the way I'm showing it to you. So usually we have 3 fields when you're changing mod, 666 or like 444, 555. I mean, you always have 3 fields. But now we have a special permissions, and we'll go over the special permissions. But just note the special permissions go in the front. So if you want all of them turned on, like if you want the setuid, which is this, which equals 4, and the setgid and the sticky bit on, you do 7555. To equal this with the special permissions, right? That's exactly how you would do it. If I just wanted the setuid, I'll put 4. If I wanted the setuid and setgid, I'll do 6. And if I just wanted the sticky bit, I can just do 1 because it equals 1. Okay. But how does it translate over here? So the way it translates is that if you have the setuid on, it will be a S here. If you have the setgid on, it will be a S here. And if you have the sticky bit, it will be a T here. Okay, so the letters will be capital if there's no execution bit. So over here, you see there's an execution bit that allows you to execute. So anybody else, let's say if this was a script, that means anybody else can execute the script. But if it's a capital letter where the special permission is, it just means that there's no execute bit. Same thing with this. If the S is lowercase, you know that there's an execution. If it's uppercase, you know that there is an execute bit on it. Okay. And we'll explain what setuid is. So setuid is basically something that you turn on or something that you set on like a script, let's say. And let's say you need someone to run a script as root. It'll run it as root for that time of execution. So let's say you wanted to run something that requires root privileges. Instead of giving root privileges to the person, it allows you to run it as root. Because that command or script might do things that only root can access, and that's the reason you would use this, is because the setuid lets you run the script as the owner of the file. So if it wasn't root, let's say if it was somebody else that owned the script, and let's say that their script has things in their directory that only they can access, maybe like data for the script, maybe some database or something that only they can access. So the setuid will effectively let you run it as that user, inherit its permissions, and do what it needs to do until the command is done. So that's the reason you would use that. The setgid, there's 2 ways you can use this. The number 1 way is to run the actual script or run stuff with the group permission. So whatever is being ran as that group. So with the setgid, let's say if I made the admin, if I put a setgid and the owner was admin, that means when you run that script, even though you're not in the admin group, you're going to run it as you're in the admin group. And then the other reason why you would use this is because if you have a folder, right, or you have a directory. So let's say if this directory right here, let's say my /home/tom/ admins, let's say if this directory here, right, any file under here that's created, it will belong to the group. So if I did file1.txt, and then Tom created another file, and then Sally created a file, and then David, and then Lucas, and then Marcus, and then Lorenzo, and they created a file in admins, that means whatever, since that setgid is set on this actual folder, that means anyone that creates a file, it will inherently become the actual group owner on this. So basically whoever's the group owner of this, so let's say the admin group is the group, right? Anything under here will be under the admin group. So that's what you'd use it. So remember, setgid can be used for running it as the group with the group permissions, or any folder in that directory will be, when it's made, instead of being made, like if I make a file now, as you can see, it becomes the Sally. Sally is the owner and Sally is the group. So when you make a file and you have a setgid bit on, it will be, basically you'll still have your username on it, but the file, it's under the group that it was created in. So if, like I said, if admin's a group and you created under the admins folders, that means that the admin group will be the owner of that file, you know, in that field. So in order to change it, I'll show you guys how to do it. We can do chmod, and let's say if I want to activate setuid, setgid, and then the sticky bit, you'll do 777. And we'll go over the sticky bit right now because I definitely skipped over that. So what the sticky bit is that if you enable that in a folder, let's say, and let's say you're in a group folder, right? And it basically enables it so that way you can't delete your friends or your other coworker stuff. So like if you have the sticky bit on, you cannot delete John's and Sally's because it's not your folder, but you can delete your own folder. So this is made so people can't delete other people's files if they're not the owner. The only other person that can delete it is people with elevated privileges or root user. So if you're the root user or have privileges that's able to do that, then yes, you can do it. But remember, the sticky bit is so people are not allowed to delete your files without you deleting it or the root user deleting it. So if I did 777 on file.txt, I'm going to enable all those bits. And if I do ls-l, we can see, I forgot to add the actual 7 in the front because the extra 7 in the front is the special permissions. So if I do ls-l, you can see now we have the S, we have the S, and we have the T. So the T is for sticky bit, the S is for setgid, and then this S over here, because it's in the owner area or the user area, it's for the setuid. I remember the middle one, if you see a S, is because it's the group section, so it's the setgid. So now that we see that, and the reason why it's lowercase, because remember it has the execute bit behind it. But let's say if I changed it, and as you know, that if I just give it read write and no execution bit, you know how it looks like. It will look just like this: read write, read write, read write. But let's say if I added the 7, which I want to enable setuid, setgid, and sticky bit, and if I did ls-l, as you can see here, it's capital because there's no execution bit. That's the reason why it has capital letters. Okay, so when we're changing the mod for these permissions is the same thing. So let's say if I wanted to minus, like for the others, I want to minus a sticky bit, you can do O minus T for file.txt. And if I do ls-l, you can see the sticky bit went away. But let's say I want to minus it for the group, it wouldn't make any sense and it wouldn't do anything because the groups don't get sticky bits. So if you did that by accident, it wouldn't do anything. It wouldn't affect you essentially. But let's say I want to take it out the user and the group, and I want to take out their setuid bit, you have to use the S. And if I do ls-l, as you can see, it's disappeared. It used to be here. Now it's disappeared. And then when I minus the T, which is over here, we can see that once we minused it, it's gone. And then over here, it's gone too. And the reason they're capital is because there was never an execution bit. So if there was an execution bit, you would see it like this. You would see, I'll do 777. And then I'll do ls-l. And if there was an execution bit, right, you can see it here. So if I did chmod plus, group, actually I'll do all of them, plus sticky bit, and then the setuid, setgid, and then the sticky bit here. It wouldn't make a difference because if I try to run a sticky bit, turn the sticky bit on the setuid area, it wouldn't work, or even on the group, it won't work at all. So like basically, essentially, I'm doing this so I don't have to do multiple commands. So I would have to do one command, a plus s, a plus or ug plus s, or other plus t for the sticky bit for others. But I'm doing it this way because it's a lot simpler. And if you do it this way, as you can see, you can turn on the permissions, RWS, RWS, RWT. And if we remove those permissions, for all of them, we can see that it's lowercase. The execute bit is here, but the reason why it's lowercase because you have the execution bit behind here. So just to refresh, if you're doing change mod, 777 equates to read, write, execute because 4 equals read, 2 equals write, and then 1 equals execute. And the number in the beginning of it, which is here, 777, which is the first number out of the 4, is for special permissions. And for special permissions, the setuid is 4, the setgid is 2, and the sticky bit is 1. That's exactly how it works. And if I do ls-l, as we can see here, we have rewrite, execute. And if I want to change it and I want to add like, let's say read, write, and then no permissions on file. As you can see here, we can see that read, write, read, no permissions, and that's it. And then if you want to use a numerical, the symbolic versions, use UGO, which user group and others, and then A for all of them, and then plus or minus depending on the permission, and then read, write, execute, and then S for the setuid, setgid, and then T for the sticky bit. But remember, if you do it on a field that doesn't apply to, it would just skip it. It won't work. All right, that's going to wrap it up for today. It was a quick video just to go down with Linux permissions. If you have any questions or anything else, please comment below. I'll love to help you guys out. The next video that I'm going to be working on will be a access control list, which you guys can learn more about access control. And I hope you enjoyed this video. Thank you very much.